Hey everyone, welcome to video walkthrough number 3 for IT Guru Lab 3, Hubs, Bridges, and Switches. And we're not going to cover 100% of the content that's in the lab document, but we do want to go through just real briefly, kind of a quick recap of the lab so that before we walk through setting up the scenario, we kind of know what we're dealing with here. So just to quickly go through it, we're talking about hubs, bridges, and switches. These are interconnection devices that are different than a router. A router is used to route packets in between networks, but the hub, the bridge, and the switch are interconnection devices for LAN, for connecting computers at the local area network level. And the first connection device we want to talk about is the hub. Now, the hub operates at the physical layer, layer 1 of the OSI model, which means that at that point, all of the data that's being sent is basically just bits. They're electrical impulses. The hub doesn't do any kind of intelligent translation. It doesn't look at the bits as frames or packets or anything. They're just bits at that point, and the hub is a very simple device. All it does is receive packets or receive bits on one of its ports, and it repeats. It boosts the signal and it repeats those bits out to all of the other ports. It's just a repeater. And that means that it's a pretty dumb device. It doesn't have any sort of intelligent forwarding capabilities. It's very simple. And when we talk about a hub, we've got the hub represents one broadcast domain and one collision domain. When we say broadcast domain, that means that any packets or any bits that the hub receives, it retransmits out to all its ports. So that would mean that all of the devices that are connected to the hub receive traffic that comes from all of the other devices. Now that traffic may not be intended for the other devices, but everybody can hear it. They're all in the same broadcast domain. Now when we say the same collision domain, we mean that all of the packets that come into the hub have the potential to collide with each other. They aren't segregated in any way. So if two devices that are connected to the same hub transmit bits at the exact same time, and those bits arrive at the hub at the exact same time, there's a collision and devices will have to retransmit. Let's move on to the bridge. The bridge is an interconnection device that traditionally when we say bridge we mean a device that has two ports, and it's used for connecting two network segments together. So it operates at the layer 2 of the OSI model, which means that the data link layer. So the bridge is looking at frames. They're not just bits anymore. The bits have been assembled into frames, and that means that the bridge can make some intelligent decisions about the way that it forwards packets, or the way that it forwards its bits in the frames across. So if a frame comes in on one port of a bridge, the bridge has a forwarding table that allows it to decide whether or not it should transmit that frame to the other side of the bridge. It looks at its forwarding table, and if it doesn't see the destination device on the other side of the connection, it'll just drop the packet. That means that the bridge represents a single broadcast domain, because a bridge will still send broadcast packets across to its other side, but it divides it into two collision domains. So a device on one side of a bridge can send out a message, and a device on the other side of the bridge can also send out a message, but those two messages can arrive at the bridge at the same time without causing a collision. Let's move on to the switch. A switch is a multi-port bridge. It also operates at the data link layer, layer 2 of the OSI model, so it's dealing with frames, and it also has a forwarding table. Essentially it does the exact same function as a bridge, except for it just has more interfaces. And by doing this, it doesn't have two collision domains anymore, but it has multiple collision domains. Each interface represents an individual collision domain. And that means that the switch is able to achieve much higher throughput than the hub, because there's much less packet collisions. That also means that the switch is able to devote the full bandwidth to each one of its links, whereas the hub has to share bandwidth across all its links because it's having to retransmit the bits every time it receives them. So that's just a real quick recap of what's taught in the lab guide, and I would suggest reading the lab guide to get a little bit more detail on each of these 3 devices. But the purpose of this video is really to walk through the IT Guru segment of the lab, so why don't we do that now.